Good morning, everybody. As we're getting everybody logged in here, just want to get started. Two goals to accomplish today. Number one is I do want to review for your test that's coming up on Wednesday. As I've mentioned before, you will be able to start early if you want to. I'll be sending that test out right after class is done today, so your contacts at your school will have that. So if you have time and want to arrange with them to start the test early, you can do that anytime after probably about 1 o'clock this afternoon. Second thing we want to accomplish today is the recording for last week, Wednesday, did not work. So I want to make sure I take time to go over the concepts from Wednesday that would have been in that recording that didn't take. So the way we're going to accomplish both of those at once today is we're just going to review for the test. And when we hit those topics that we covered on Wednesday, I will stop and I'll do some examples and go through those in a little more detail. So for test 5 coming up on Wednesday, the first thing, the most basic things that we need to be able to do is to calculate measures of center and spread. So for measures of center, you need to be able to find the mean, the median, and the mode. We went over those calculations on Monday, so if you're looking for those, that'll be in Monday's recording. And then measures of spread. Notice I left off the mid-range. We talked about the mid-range in class. That's one that's has only specialized uses, so we're not going to test you on that. And for spread, we had the range and the standard deviation. And now remember, the standard deviation is a fairly long formula, so I'm not going to give you a huge data set for it. Use like maybe 5, 6, 7 numbers maximum for that. Let's take a look for standard deviation. So I'm asking you to find the standard deviation for a data set. Let's just do a 5-number data set. 4, 9, 10, 12, and 15. So remember, step 1 is to find the mean. And so to calculate the mean, we just add them up. So 4 plus 9 is 13, plus 10 is 23, plus 12 is 35, plus 5 is 15, plus 15 is 50. Let me double check those here again. 13, 23, 35, 50 is correct. So that's 50 over 5, giving us a mean of 10. Step 2 was to subtract the mean from each. And by each, I mean from each number. So I have my numbers, 4, 9, 10, 12, and 15. And I'm going to subtract my mean of 10 from each. So 4 minus 10 is negative 6. 9 minus 10 is negative 1. 10 minus 10 is 0. 12 minus 10 is 2. And 15 minus 10 is 5. Remember, these numbers were called the deviations, or if you want to be more specific, the deviations from the mean. Step 3 was to square the deviations. So remember, negative numbers squared are going to become positive, so be careful entering those in the calculator. Negative 6 squared is 36. Negative 1 squared is 1. 0 squared is 0. 2 squared is 4. And 5 squared is 25. Step 4 was to add them up. Find the sum of those squared deviations. And here it looks like they add up to 40, 65, 66. Step 5 was the tricky part. If it's a sample, we divide by n minus 1. Remember, n is the number of numbers in the sample. Little n is the number of numbers in the sample. If it's a population, we divide by capital N. Remember, capital N is the number of numbers in a population. Well, everything we work with is going to be a sample. So we're always going to be dividing by n minus 1. There are 5 numbers in this list, so we're going to divide by 4. Dividing by 4 gives us 16.5. And if you recall, that number had a name that is called the variance. In advanced statistics, the variance is more useful, but in basic statistics, we tend to use the standard deviation. So we need to do step 6, which is the square root of the variance. So that'd be the square root of 16.5, which is going to give us 4.06. That is our standard deviation. And remember, what that really meant was, on average, that's how far each number in this sample is away from the mean. So a little over 4 units away from the mean on average for our numbers in this sample. Now, an important relationship is formed between that range and standard deviation. I keep writing my range with a D, I don't know why. And it's pretty simple. Both of them describe the spread of a number, or a set of numbers. So if I have 2 data sets, data set A, and I have 3, 9, 11, 13, 14, 17, 21, 28, and 34. And I have another data set B, which is 8, 11, 13, 15, 16, 19, 23, 27, and 29. And I ask you, which one has a larger standard deviation? Well, both of these, I believe they have the same amount of numbers. There might be one more in data set B. But you can very quickly see that data set A has a bigger range. The range there would be 34 minus 3, which is 31. Data set B has a range that's 29 minus 8, or 21. So since data set A has a significantly larger range, and they have the same number of items in them, we can very quickly conclude that data set A also has the larger standard deviation. So we don't have to go through that whole calculation for both of them. I mean, there's a lot of numbers there. That process of calculating the standard deviation would be pretty tedious for each of those. So I can just look and see, hey, they're the bigger range. I know that has to be the bigger standard deviation because both of them describe the spread of the numbers. Okay, so moving on from there then, we looked at organizing data, or summarizing data. We looked, most of this was in the last unit. We looked at our graphs, where we did the bar graphs, and circle graphs, and so on. Well, we've already tested on that, so I'm not going to test you on that again, but we do still need to be able to make that frequency table. So if I asked you what your plans were after high school, and you had college, work, or military, and we looked at responses, we had, just listing out C, W, and M. And it's listed them like that. So if I wanted to look at that data set and figure out, well, what are students going to do, I would have to count each individual response. But I could make that frequency table where I have college, work, and military listed here. And I'm going to count up their frequency. There's 1, 2, 3, 4, 5, 6 going on to college. 1, 2, 3, 4, 5, 6, 7, 8 going on to work, and 1 going into the military. So now we can look at that frequency table and very quickly get a feel for all the data. So then the next step from just organizing the data was using some of this numerical summary to describe data. And so we had two processes where we used the numerical summary to do that. Both of them involves using the center and the standard deviation. And for the center, remember we talked about if we have normally distributed data, the mean, median, and mode will all be the same number. So what we're going to use for the center is the mean, because we have to have the mean to calculate the standard deviation. And of course, we have to use the standard deviation. Now, I'm going to abbreviate standard deviation simply SD, save a little time here. And so one of the tools that we used was something called the empirical rule. What the empirical rule said, and your textbook uses something called the exact empirical rule. Some use an approximate empirical rule, but that's fine. The empirical rule says is if we have normally distributed data, it's going to be distributed in a bell curve like this. And of course, the center of that bell curve is going to be the measure of center, or the mean. And as we go out in each direction from that mean, if we go in steps of the standard deviation, there's a predictable number of values or percent of values in that range. For example, if we go out 1 standard deviation on each side. So this would be 1 standard deviation below, so minus 1 SD. This would be 1 standard deviation above, so plus 1 S standard deviations. We expect 68.3% of all the data to be in that range. We go 2 standard deviations, so this would be minus 2 standard deviations in this direction, and plus 2 standard deviations in this direction. There we go. What's that? We expect to find 95.5% in that range. And then a 3rd standard deviation, negative 3 standard deviations now, and positive 3 standard deviations. We expect to find almost all of it in that range. It comes out to be 99.7%. Anything outside of that range, by the way, is what we consider an outlier. It's very unlikely to happen, and it could drastically affect our data. Let's take a look at what this really means. Let's say we're looking at the cost of an X-ray. Let's say industrial standards, the cost of an X-ray. Actually, let's not do X-ray. Let's do of an MRI. That'll be a little bit. I don't want to use the same example that's on the test. So an MRI. Let's say the MRI has a mean cost in your region of let's see, $1,200, and a standard deviation of that cost. Let's put it at $220. So what that means is on this curve, the mean, the center is 1,200, And as we move to each step, it's a difference of 220. So let's go to the right first. So we're going to add the standard deviation each time. So 1200 plus 220, this will be 1420. This will be 1640 and 1860. We just added the 220 standard deviation for each step. Going the other way, we'll subtract it. So this will be 980, 1200 minus 220. This will be 760 and 540. And so what that means is if I want to know what percent is between, let's do 760 and $1,640. Well, look here, here's 760 right here. Over here is the 1,640. We see that's the 2 standard deviation range. That's the 95.5%. 95.5 or 95.5% of all MRIs will cost between those two numbers, between those two values. Or I might ask what percent is greater or more than 1,200. Oh, this one's a little trickier, but 1,200 is right in the middle here. More than would be this side. Well, this curve is symmetrical. So remember, one of the things about the mean is it's the middle. Well, not the middle, it's the average, but since it's normally distributed, it's also the median. So that means half of the data is on either side. So since 1,200 is the mean, 50% of the data is larger than 1,200. So if you recall from Wednesday, we could use this empirical rule to get very, very specific percentages of the data that are in each of those ranges. If a doctor quotes you a cost of $1,640 for an MRI, you look up here and you see 1,640 is right there. If I want to figure out what percent is less than that, well, I have 95.5% is between the 2 standard deviations. I actually have this piece left to add on to that. To figure out how big that piece would be, we got to do a little bit of creative math here. Get from the center over here would be half of the 95.5. That's 47.75. So that means since 50% is to the left of the mean or less than the mean, this is 50 minus the 47.5, giving us 2.25% out here yet. So the amount that would be less than 1,640 would be the 95.5% plus an additional 2.25%. Adding that up is 97.75% of all MRIs are cheaper than that price. So what that's telling us is we can probably go somewhere else and get a cheaper MRI than the price that the doctor quoted. This is one, if you go into the medical field, it's a good analysis. But even if you don't go into a medical field, understanding this curve, the empirical rule and the bell curve here, and how they work together is a great way to be an informed consumer. It's really easy to do market research and find mean and standard deviation prices for products and for services. And so a lot of people don't get a quote in advance for a medical, something like that, if it's a non-emergency thing. And you have every right to. If you get that quote, you'd be surprised there's a huge difference in price from one location to the next on what some of these things cost. And so understanding this bell curve, the empirical rule, and those percents, you can get a quote and look at the mean and standard deviation for your area, and you can decide whether that's a good price or a bad price. And you might look at it, okay, it's a decent price, go ahead and have it done. Or if it's a bad price, you're going to check with a couple other places and see what they're going to charge. Not just in medical services, for just about anything you're going to have done. It's a great way to analyze those things. even when finding a job and analyzing whether the salary you're being offered is a good deal or not. That's one way to break it down. Now, very closely related to the empirical rule is a thing called a z-score. And a z-score is one of our first measures of position. The other one we talked about was percentiles, quartiles, and all those that we mentioned on Friday. So anyway, I mentioned a little bit on Monday as well. So measures of position. Z-score being the biggest one, what the Z-score does, it allows us to compare things from different populations because we're comparing a value back to its own population. And by doing that, like I said, we are now able to compare values from different populations. And the example we used was, let's say we're managing a store and we want to fire one of our sales staff. So we're going to have person A and person B, and we're going to give them a week. And whoever has the worst sales at the end of that week is out the door. Well, let's say that salesperson A, employee A, has sales of $1,800 that week. And salesperson B has sales of $3,400. Now you could look at these and say, yep, A is gone. That's way lower number of sales. They have to go. But we need to be fair about this. Person A is working in toys, while person B is working in electronics. Probably not a level playing field. The demand for electronics is pretty even year-round. Toys spike around Christmas and then drops off quite a bit the rest of the year. And also, electronics tend to be more expensive than toys. So to make this a fair comparison, we compare each of them back to their population using a z-score. And a z-score, the z-score for a number is just the number minus the mean for that population and then divided by the standard deviation for that population. So we need to know the mean and standard deviation for each of these. So for that week, for all salespeople in toys, the mean sales was $2,900 with a standard deviation of $400. All people in electronics, the mean sales was $4,300 with a standard deviation of $300. So let's use the z-scores to see who was really further away from the standard. So the z-score for employee A here, they had $1,800 in sales minus the mean of $2,900 divided by a standard deviation of $400. So 18 minus 29 is a negative $1,100. So that's saying they're $1,100 below average, below the mean. Divided by 400 is a negative 2.75. So two things here. The negative tells us that they're below the mean. 2.75 means they're 2.75 standard deviations below the mean. The standard deviation here becomes a standardized unit of measurement. So let's do employee B. Their z-score, they had sales of $3,400 minus a mean of $4,300 divided by a standard deviation of 300. So 3,400 minus 4,300 is a negative 900, so they were $900 below average. Divided by that standard deviation of 300 is a negative 3 z-score. So the negative again means they're below the mean, but this salesperson was 3 standard deviations below the mean. So this one is 2.7 standard deviations below, this is 3 standard deviations below. So employee B actually had a worse week of sales. Their performance was lower. That's the one we should get rid of. So here we're comparing two things from totally separate populations. Wouldn't be fair to make a direct comparison, but by using that z-score to turn it into a standard unit of measurement, the standard unit of measurement here is just the number of standard deviations from the mean, we're able to compare these things from drastically different populations. Moving on from that, then we looked at doing some calculations of center and spread from grouped data. So let's say we had a list, we want to survey college students to see how many classes they're taking. I'm actually going to do that. We'll do it right. Let's say they're taking 0 classes. We don't consider them to be a current student. So we're going to go 1, 2, 3, 4, or 5 classes. And we get the frequency here. So the students we surveyed, let's say 10, we're only taking 1 class. 25, we're doing 2 classes. 35, we're doing 3 classes. 15, we're doing 4, and 15, we're doing 5 classes. So here's our frequency table. And remember, what this means is the value of 1 occurred 10 times. So if I was listing this data out, we would have 10 ones listed out. And the value of 2 occurred 25 times, so that would be followed by 25 2s. I'm not writing out 25 2s, obviously. And then 35 3s. And then the 15 4s and 15 5s. So this is just a way of reducing the size of this data set, making it more manageable by using the frequency table. So if I really needed to, I could list out all these values like this and add them up to find the mean or find the median from them. But I don't want to do that. I don't want to go through all that work. So let's use the frequency table to shorten that process. Let's start out with the least useful one, but the easiest one to find, the mode. The mode, remember, is the value that occurs the most often. The 3 occurs 35 times. That's our mode. So the mode here is 3. The next easiest one to calculate is the median. So we have to find the position of the median, and we do that by finding n. Well, n here is found by just adding up the frequencies. So 10 plus 25 is 35, plus 35 is 70, plus 15 is 85, plus another 15 is 100. There's a total of 100 here. So to find that position, it's 100 times 0.5, which is 50. So remember, that's telling us that we are going between the 50th and 51st numbers to find the median. Well, let's look at this. There's 10 ones. That means the first through the 10th number in the list are ones. The 2s then start at the 11th number. Now remember, do the 10 plus 25 gives me 35. So the 11th through 35th number are 2s. Remember listing these out, 1, 1, 1, 2, 2, 2, so on. This is how many there would be. So then the 3s start with the 36th number, and 35 plus 35 would be 70. That goes up to the 70th number in the list. Well, we want the 50th and 51st number. That's going to be between the 36 and 70. So both the 50th and 51st number are 3s. So the median of this data set is a 3. So those are the easy ones. The logic behind the median can be a little tricky if you're not used to working with it, but it's not terrible to calculate. Let's find the mean. So to find the mean, we have to add, the first step is to add them up. Well, to add them up, we have to remember that there are 10 ones. So I'm going to call this x, and this the frequency of x. I'm going to take each value of x times its frequency. So 10 ones, 1 times 10, that adds up to 10. 25 2s, 2 times 25, that adds up to 50. 35 threes, well, 3 times 35, that adds up to 105. 15 fours, 4 times 15, that adds up to 60. And 15 fives, 5 times 15 is 75. We add that all up, we get what, 180, 240, 300 is what that adds up to. That is our total right there. That is the sum of all of our values. And to finish off the mean, remember we divide that sum, 300, divided by the total, 100, giving us a mean of 3. So the average number here is 3 again. For spread, we can find the range. Well, the biggest number in this list is a 5, and the smallest number is a 1. So the range is simply 5 minus 1, or 4. That's not very interesting. So let's look at the standard deviation. The first step in the standard deviation is to find the mean. We have that. Second step is to subtract. Let's do that. So remember, the value here is this column over here. This is our x value. So what we're subtracting is the mean of 3 from each of those values. So we have 1 minus 3 is negative 2. 2 minus 3 is negative 1. 3 minus 3 is 0. 4 minus 3 is 1. 5 minus 3 is 2. So those are our deviations. Next was to square each of those. So negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Now our next step would have been to add these up. But remember, there's multiple of these. There's not just one 1. There's 10 ones, which means this 4 occurs really 10 times. So we have to add up 4 times 10 is 40. 1 times 25 is 25. 0 times 35 is still 0. 1 times 15 fours is 15. And 4 times 15 fives is 60. And we add those up to get 140. The standard deviation then is the next step in the standard deviation is to divide by n minus 1. So we're going to divide by 100 minus 1, or 99, which gives us 140 divided by 99 is 1.414. That's our variance. We still have to do the square root to get the standard deviation. So the square root of that is 1.189. That is our standard deviation. I know I flew through that kind of quick, but we have a lot to cover today, so I wanted to make sure we got through everything. This recording will be posted really soon after class, so you can review it. So then the final thing we talked about, and this we talked about on Friday, and so this is in the recording out there posted for Friday. I'll double check to make sure it's posted after class, was probability. And probability is how likely it is that something will occur. And we used 2 types of basic probability. We used a probability distribution, where I have a table listing all of the possibilities. And then each of their probabilities. So we might have something, well, let's look at the number of classes again. Number of classes taken, so that's x, and this will be p of x. Instead of the frequency, it's the probability of x. So if we're surveying students to see how many classes they have, and let's see, the probabilities now are 0.1, 0.25, 0.35, 0.15, and 0.15. First of all of these probabilities here have to be between 0 and 1. Probability of 0 means it's impossible. 1 means it's guaranteed. So in real life, those probabilities all fall somewhere in between there. Second is this total has to equal exactly 1. And I'm pretty sure that one does. It does. 1 or 100%. So we look at what's the probability. P of 3 is saying what's the probability that a randomly selected number equals 3, or item equals 3. Well, that's just the 0.35. If I asked what's the probability that being at least 3, well, at least 3, that would be 3, 4, or 5, so I just add those up. 0.35 plus 0.15 plus 0.15 gives us 0.65 probability. Now, a very subtle difference between that one and this one. Probability being more than 3. That one does not include the 3. 3 is not more than 3, so it's only 4 or 5. So we add those up. 0.15 plus 0.15 is 0.3. You have to be very careful reading those questions for those probabilities. The second type of probability we looked at is something called a contingency table. And let's use our contingency table here to look at type of doctor visit. And income. And we're just going to do for income, we're just going to do low and high. Type of doctor visit, we're going to do ER. Outpatient. This would include a regular doctor's visit for a clinical visit, and then inpatient. So for let's say that we take random samples of patients and we find that we had 47 in the ER for low income. We had 33 that were outpatient and 14 that were inpatient. For high income, we had 31 that were in the ER. We had, let's do 53 that were outpatient and 22 that were inpatient. So to use a frequency or a contingency table, like, first step is to find some totals. Let's find the row totals. 47 plus 33 is 80, plus 14 is 94. 31 plus 53 is 84, plus 22 is 106. So we have 94 low-income patients, 106 high-income patients. And we also need the column totals. 47 plus 31 is 78 ER visits. 33 plus 53 is 86 outpatient visits, and 14 plus 22 is 36 inpatient visits. Adding those up, we get a grand total of 200. So that's the same total this direction as it is this direction. If it's not, we did something wrong. So you need to go back and double check your totals if that's the case. So we ask, what's the probability that a randomly selected patient is low income? Well, there's 94 low-income patients out of 200. That's just 94 out of 200. Or if you want, you could leave it like that. That's just fine. Or you can divide that out to be 0.47. We might ask, what is the probability that a randomly selected patient was an outpatient? Well, that's 86 outpatient patients out of 200, so that's 86 out of 200. Again, you can leave it as 86 out of 200, or you can divide it out to 0.43. But it can be trickier than that. We might ask, what is the probability that a randomly selected patient is, high income and an ER patient? So since this is and, that means it has to make both things true. Here's the high income, here's the ER patient. The only ones that are true for both are these 31 here that are both high income and ER. So that's 31 out of the grand total of 200. Again, you could leave it like that, or you could divide it out to be 0.155. Slightly different than that would be the probability of being high income or an ER patient. Here, it just has to be one or the other. So these are the high income patients, these are the ER patients. We just have to add those four numbers up. So we have 47 plus 31 plus 53 plus 22 is 153 out of that grand total of 200. 153 out of 200, or 76.675, I should say. 0.765. 0.765 is that probability. The final thing that comes into that is conditional probability, where we already know something about the answer. We ask, what's the probability that this is a low-income person given that it was an ER visit? So what this is saying is we know already that it's an ER visit, so we're only looking at the 78 ER patients. What's the probability that it was a low-income patient? Well, there are 47 low-income patients out of those 78 ER visits. We can divide that out, maybe, giving us 0.603. Now, it looks very similar, but it's different. If I say, given that it's a low-income patient, find probability that they're in the ER. So now we're saying that we don't know that they're in the ER, we know that they're low income. So we're only looking at the 94 low income patients. Of those, 47 were in the ER. So it's still a total of 47, or 47 patients that meet the qualification, but now we're looking at the low income as our total rather than the ER as our total. So that's out of 94. That comes out to be exactly 0.5. So a very different probability. So that's what we had covered on Friday. I know many of you were gone on Friday. That recording is posted out there for you. I'll make sure it's clear and working for you so you can review. So as I said, I will get this test out immediately after class is done, so you can start anytime you would like to between now and class on Wednesday. We will take class on Wednesday to work on the test. I will need it back to me. It has to be complete by 12:30, what would normally be about the end of class on Thursday. I'll be logged in on Wednesday if you have any questions on the test. This is a shorter test, but statistics is a trickier concept for a lot of people. So please feel free to ask questions if they come up. There is no new homework today other than to study for the test and get started early if you like. So with that, you guys have a great day, and we'll see you all on Wednesday.